The Science of Flight, an exploration of air pressure and how airplanes work. Hi everybody, thanks for being here today to learn about flight. Before we start though, we have to learn about air and air pressure. Air is all around us, and just like everything else around us, like that truck or that tree, it has its own weight, it takes up space, and it has its own properties. And to understand this, it helps to think about molecules. Molecules are the tiny bits of matter that make up everything. And air is mostly made up of nitrogen and oxygen molecules. I know it's strange to think of air as having weight. It's hard to even imagine air being something since it's invisible and it doesn't feel like it weighs anything, but it does. There's always air pressure all around us. Everything around me right now is air pressure that's static. Let's look at the difference between a low air pressure, a high air pressure, and a static air pressure. We'll start with high pressure with this balloon, which I'm going to blow up. So, right now, the air molecules are densely packed together, and when the density of molecules is high, the air pressure is high. So inside the balloon is a high pressure environment compared to the pressure around it. Here's a question. What do you think will happen to that pressure if I release the balloon? Let's see. Okay, so what happened to that pressure? It was released. Okay, let's go over this again because it's pretty important. The pressure inside the balloon is high compared to the pressure outside the balloon. Inside the balloon, the molecules are tightly packed together, close together, creating a high pressure environment. But outside the balloon, the molecules are spread out, so the pressure is relatively lower. So, the high pressure air inside the balloon flowed out into the relatively low pressure air surrounding it. Let's look at air pressure in a different situation. Here, the fan is moving the air, and as you can see, the moving air has molecules that are more spread out than the still air around it. So, the faster air moves, the more spread out the molecules are. And we just learned that spread out molecules equal lower pressure. So that means faster moving air equals lower pressure too. In the next situation, I want you to tell me where you think the high pressure is and where you think the low pressure is. So, what do you think? If you guessed that the faster moving air created a low pressure situation, you were right. Now that we've seen how low and high pressure work, let's see how different pressures affect things in the environment. Here I've got two balloons hanging from a yardstick by string of equal length. I'm going to take a deep breath and blow right in between those balloons, and I want you to predict what will happen. Do you think the balloons will move? If so, which way? Did that surprise you? You might think that the balloons were going to go away from each other. But the fast-moving air that I blew between them actually caused the high pressure on the outside to push them together. The fast-moving air caused the molecules to spread out, and that created lower pressure. When the balloons separate again, the pressure is static everywhere. The scientist who figured this out was named Daniel Bernoulli, and from him we get the Bernoulli Principle. Bernoulli's principle states that fast-moving air exerts lower pressure than static air. Now let's look at the major forces at work on an airplane, and we'll see where air pressure fits in. First, there's thrust. Thrust is the force that moves the plane forward, and it's created by a propeller or a jet engine. Drag is the force that's working against thrust. It slows the plane down, and it's mostly caused by the friction of air colliding with different parts of the plane. And gravity, of course, is always doing its thing to pull the plane to Earth. And lift? Well, that's where air pressure comes in. In order to see how, let's take a closer look at the wing. Think of the edge of the wing slicing through the air. The slices that were separated at the front of the wing need to meet each other at the same time at the back of the wing. Okay, here's the second thing. That curved shape on the top is called an aerofoil, and that shape causes the air to move faster, and as we know, that causes lower air pressure. The straight shape on the bottom causes the air to move slower, so that means higher air pressure. That higher pressure causes lift, pushing the plane upwards. You might be thinking, wait, how do you know the air is moving faster over the top of the wing? Well, it's because the top of the wing has more surface area. Let's look at it in a different way. Imagine these two paths represent the upper and the lower part of the airplane wing. It's very exaggerated, but the upper part would be the aerofoil shape. And as you can see, it's 9.5 arrows long, but the bottom part is only 6.5. These two rabbits represent the air. Now let's imagine them getting into a race, and they have to end at the exact same time. Well, you can see that the rabbit going over the top is going to have to go a lot faster in order to make it in time. That's exactly what happens with the air molecules. I used a small scale model of a wing and dry ice to see if you could see this effect. It's a little bit easier to see in slow motion. So yes, you can see the vapor is moving more slowly across the bottom of the wing. Right now, I'm walking up to the workshop of my neighbor, Mr. Jeff. He builds his own airplanes, and we're going to take a look and see what he's doing. There are the wings. And there's the body. Let's go in and take a closer look. A lot goes into building your own airplane. It takes quite a long time. Mr. Jeff is working on it every day. Now he's showing me the switches to the lights. The body of the plane is called a fuselage, and Mr. Jeff told me that it comes to him in pieces. See all those seams? Everything has to be put together like a puzzle. And then, to make it look good, Mr. Jeff has to sand and sand and sand it. He's been sanding this plane for 4 months. Here's the wing with that aerofoil shape. And there's the wiring for the lights. That's where the seats are going to go. Inside the cockpit, of course. And there's the cockpit right there. And here are the seats without the cockpit. And there's the tail of the plane. At the beginning, the inside of the plane is just a shell, and he has to add all the instruments and switches. Here's the back of the plane. And this lever here is what you'd pull up if your landing gear wasn't coming down. More wires and switches. And this is where the propeller will go. And here's what's called the elevator and the stabilizer. I kept thinking, how does he keep track of all these wires? But Mr. Jeff said, it's like a bowl of spaghetti. You have one piece of spaghetti, and another, and pretty soon you have a whole bowl. But he knows exactly what each one is supposed to do. This is the motor that's going to go into the plane. And here's something really interesting. It's actually the motor of a 2008 Corvette. I asked Mr. Jeff, does it really have enough power to work in an airplane? And he said, yes, it actually has more power than some airplane engines. Mr. Jeff has been flying since he was 15 years old, and he's been making planes for 30 years or more. I asked him why he likes to make planes so much, and he said it's like putting together a big puzzle, and there's always something new to figure out and something to learn. This plane doesn't have wheels, it has skis, so it can land in snow. This is another one of Mr. Jeff's planes that he was in the middle of building. And here's one that he had fun flying. And here's Mr. Jeff flying upside down. Coming in for a landing. Making a paper airplane. First, just start out with an 8.5 by 11 piece of paper and fold it in half, like this. I've made a lot of airplanes in my day, but I think they don't always turn out that great because I'm rushing, so I tried to take my time with this. Fold the corners down towards the center crease. Make sure it's lined up. And then fold again towards the center. The edge of your paper is going to end up on that center fold again. Now take the point and fold it down towards where the paper first meets on the crease. The more you fold the paper, the more difficult it is to get it exactly the way you want. But just take your time. And here's the next fold. You're bringing that point again towards that center crease and then push the sides down. Next, take that little triangle of paper that looks like a beak and fold it upward. Now turn the plane over and fold it like so. And here's your final step. Just fold down to the edge of the plane on both sides like this. Okay, I think we're ready to go try it out. Honestly, I was a little disappointed at first until I saw the one my husband made. But remember, you can always make adjustments. Mine felt a little too heavy in the nose, so I cut part of it off, and it worked better. Have you ever dreamed of being an airline pilot? Listen to what this American Airlines pilot told me last year when I traveled.
My name is Dean Grant. I'm a pilot for American Airlines, also formerly a Navy pilot, spent 27 years in the Navy. To become a pilot, you have to receive flight training, and to be an airline pilot these days, you need a college education. So what I would tell you, if this is your desire, to do very well in school, listen to your teachers, listen to your parents, and the people who are trying to help you, because they will give you guidance, and do your very best and stick with it.
When you went to the Navy, did you get trained there?
I did. I received all of my aviation training in the Navy. I had a private pilot's license before going in, which I paid for, which helped, but the Navy gave me all of my qualifications. But you don't have to go into the military. There are civilian flight schools that will give you all the training to be an airline pilot.
What's your favorite thing about being a pilot?
Just seeing things from a different viewpoint.
Thank you so much.
You bet. Good luck to you guys.
Thank you for joining me today to learn about flying. If you want to earn points for Read Squared, here's your program code. See you next time.